Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're going to talk about a new technology of single shot HDR technology. So let's dive right into it. Now, what exactly is the problem? Well, the problem is that if you actually mathematically analyze a real world, for example, you have a scene here. So how much photons are coming from the shadow versus how much photon is coming from the sun, the range would be freaking infinity. And that's the real world problem. It's like no matter what you do, you cannot build a sensor that can just capture all of it because again, it goes to infinity. Now, what about our eyes? Because our eyes can see well, it creates a trick. For example, I'm looking at a camera. The camera is a very black body, but my eyes are adjusting for it. But here's the deal. The moment I look up, there is a tube lights there. Now, those tube lights are big and bright. My eyes adjust for it. Now, because my eyes are adjusting and feeding it as a scanner data, because it's like, eyes are scanner, your only focus part is just this much. Your nail at like this. That's it. That's all much you can see. And you are scanning like this. So the mental image I get is awesome. The mental image is like almost as good as nature in real world. So you cannot build a digital sensor that can match that. Nothing, not even negative. Like negative is only good for kind of highlight. If you want sensor, negative sensor, as in like digital sensor, that can go very good in low light. And both of them will give you more or less the same. And very modern sensor, as in like sensors made after 2015 with BSI, generally they can give you a bit more range than that. So there is nothing that can it's like negative no, and even negatives have limitation. So fundamentally speaking, no matter what you do, there is a limit to sensor technology, and the only way we can breach past this is that if we have higher dynamic range. For example, right now our dynamic ranges are measured, good cameras, in around 14. Now you may like some are 15, some are 16. Not really. 14 are like the clean, where you can count on it. It's very usable dynamic range, so to say. They're very good. So what we are doing in the meanwhile is what we call multiple exposure bracketing, meaning we'll take underexposure shot that gives us the overexposed shot that gives us the shadow, underexposed shot that gives us the highlight, combine both of them and voila. Now, we generally don't only do two of them. We generally have multiple, 5, 6, 7 or something like that. And it does give you truly good high dynamic range images. But it does come with a consequence. It is taking multiple shot and it's strictly for static subject, because if you try to do moving subjects, good luck. It's gonna move between all shots and you cannot shrink the exposure. Because again, if you shrink the exposure, how the heck you're going to change any vector? Because be mindful, sensors do not have ISOs. All sensors have just one gain, that is from the analog to digital circuit. That's why there are dual gain circuits nowadays that have two ISO, basically analog to digital readout system. Basically, sensors generally have only one way of gaining system. And can you improve it? Yes, you have to use liquid nitrogen to cryo cool it. And that's why like all observatories, they cool down their sensor to almost absolute zero. Then only they work perfectly. Same thing goes for James Webb. So be mindful, sensors always have only one gain. They can only change data basically in terms of time, basically how long they are exposed. They can't do electrically anything unless you have two different circuits. So this is the problem. You cannot bypass it, you cannot trick it. How the heck we gonna solve it? Because be mindful, we are reaching an upper limit. People have realized even with backside implemented sensors, 14 stops is the best we're gonna get. We really can't push beyond it. Like useful way, not really. So how do you reach 20 or 25? Well, the first time it was tried, like around early 2008, it was Assorted Pixels technology. Now, this technology is basically like putting sunglasses on random pixels, or like you create a pattern. For example, these are the patterns. One pattern you have like lines, and you have cross lines, and all of them have different shades. As in like the naked sensor area will have like, let's say 0, as in like no temperament. One line would be like 4, another line would be 8. So you have 4 ND filters on the sensor itself. So sensor gets high data and low sensitivity data at the same time, meaning you click it, it gets all the data. It has basically high exposure, low exposure, all of them at the same part. Because again, from sensor's point of view, sensor has ND filter and does not have ND filter, and has like medium ND filter, all of them. So it gets all of the data in one shot. Click, done, all the data. Algorithm combines it. Now be mindful, I'm talking about ND. This does not mean it only can be done by ND. Other mobile phone companies, they are using polarizer, meaning they have different polarizer. So it has a bit less of effect, but does give you the same effect, where light will behave differently with different part of the sensor. So some of the sensors will be like very easy to overexpose, some would be very hard to saturate, meaning good for highlights, some would be good for low lights. All of that combines. So algorithm combines the data and gives you the delivery. Now it does come with a side effect that is very poor at low light performance, meaning if you are taking a photo at absolutely low light, outdoor scenarios, it's not going to work very well. But it does beat any camera, no matter what you do, no matter what kind of quality or RE, Alexa, Red, whatever have you, it's gonna bitch slap all of them. This is a normal high-end camera. This is Assorted Pixel camera. You can literally say, and it's one shot. It's not like multiple bracketing. It's one shot. It's like voila. It exposes very well for the highlights, but here highlight is there, shadow is also there, and nothing is overblown. So everything fits inside the boundary layer. Meaning, if you want to fit it in 8-bit technology, you can fit it. You can want to fit it in 10-bit, you can fit it in 10-bit. You have no limitation there. Again, even in low light also it does work, because if you have things like Christmas light or things of that nature, those will be exposed properly, and things that have like a very bright billboards, those will not cause overexposure. So it does work even good at low light scenario, but the grand total performance does go down, meaning you have to use way too much noise suppression, because be mindful, you just put sunglasses on it. So fundamentally, this is a good way of getting basically 4 sensor for the price of 1 sensor. You just have to work harder on basically fabricating, because it's an extra layer that goes on top of sensors. Some company use a random noise mask, like that noise is very what you call regular. Some companies have random spotters. Again, each of them pros and cons and all that jazz. So this is Assorted Pixels. Does work very well, does give you like crack all one shot. HDR output is really good, but at low light performance is really bad, because again, you inherently put ND filter on it. Then we come to the dual gain, and I'm not talking about dual ISO gain system. This is a different system. Now here you have 2 set of pixel in one sensor, meaning your sensor, if you go electrically, it's like there is bank A and there is bank B. Now how those will be arranged, that's up to you or the manufacturer. For example, it could be diagonal like this. It could be basically horizontal like this. It could even be vertical. So basically you're gonna have 2 subsystem in one system. So you're gonna look at it, it's like, okay, it's one sensor, but you look electrically at it, it's like, okay, there are 2 sensors, basically 2 sub-circuit there. Now dual exposure is taken in one shot. Now be mindful, I specified there is no changes in ISO. You can't change ISO unless you have like physically different circuit. You can't change with it. So what can you change? Well, you can shrink the exposure. For example, you are shooting a video. Let's say you are making a camera, you want to shoot a video. Now what does the camera do? You feed it data, hey, give me 1/30th of a second. You want to shoot at 30 FPS. Now that becomes exposure A value. So A value becomes 1/30th of a second, which we call long exposure. Then the B sector, again, because B is independent electrically, it has the ability to shrink down. Now like, why the heck it shrink down? This is the easiest way to handle basically overexposure part. So 1/30th, let's say 1/30th is good for the dark part, but it will overexpose the bright parts. You like bright parts will be controlled by B. It will go down to 1/300th of a second. Now it works very well in low light. It works very well in high action also, and all of that is done in one shot. And the best part of it is that you have independent control of second system, meaning the sensor gets data. The sensitivity controller have knobs to it, meaning it can tune it. Now long exposure is tuned by the user, meaning you want 1/60th of a second or 1/30th of a second frame rate of a video. Basically that is limiting the long exposure. You can't stress past it, okay, that limits it. But here's the deal, the short exposure can go as short as you need it. For example, its camera studies it. Let's say camera, your mobile phone array has a black and white camera. It's very good at dynamic range, and it studies the scene. Is like, bro, I think this short exposure should only be like 1/300th of a second. That's gonna give us a good job. Voila, you have one shot system. In some sizes, like, you know what, I think 1/50th of a second will do the job. Awesome. If it detects it like, dude, it's pitch black, it's like, okay, let's make it 1/30th of a second. So you do not suffer the low noise penalty that you suffered in Assorted Pixel design. So that's the whole benefit of it. You basically have 2 sensors behaving with 2 exposure control. You have one primary exposure, that is the long exposure, second short exposure. So this puppy handles highlight like there is no tomorrow. And because you have electrical control over it, it's not like fixed system. It's not like, okay, it can only do this much. It's like, okay, whatever you need to stretch it to like, let's say full length for very low light, awesome. You want to stretch it to very short level, no problem. Like in some scenarios, this can be stretched to 1/10,000th of a second. For example, let's say a car is coming at you. So in those sort of scenarios, this ultra short exposure will save that footage also. So fabrication is rather simple. Algorithms are also very simple. It's very good for sharp motions and low light performance. And it's a core of right now many mobile phones that are genuinely good. And you take a photo, it's like, damn, this puppy is good. Dual gain technology. So it has 2 systems that is taking care of it. Now be mindful, it's unlikely that it is available in any mid-range smartphone. The sensor is expensive, because be mindful, it has to build 2 sensor for the price of 1, and not to mention I have 2 electrical sensor for a location of 1. So fundamentally it does cost a lot of money. but output is genuinely good, meaning if camera technology is truly using this, you're gonna have amazing thing, and it's used in industrial vision application without any consideration. It's like, this is truly amazing. This is dual gain, and be mindful, the control vector, awesome. Then we come to the regional exposure. Now this puppy became popular because Canon recently announced a system. Now be mindful, it's not that Canon is the only company that has it. Nikon also has their own sensor that does the same thing. But if I'm directly comparing both of them, the Canon does have one extra stop. So it's almost like 21 or 24 stops of dynamic range. So stupid range. So how the kit has that? Well, it has many pixel clusters. In the last model, we have two sensors. Here you have basically subsets pixels, many pixels combined acting as a one system. Basically how you see a modern mirrorless camera. It says now it has 700 points of autofocus. Same thing here. It has 700 points of regional exposure control. So anytime you buy a Pixel phone and you're like, how the heck Pixel is doing such a good job in daylight? What Pixel is doing is basically we call single shot HDR, but it's single shot to you, not to the camera hardware. What it's doing in camera hardware, let's say you want to shoot a video, it's 1/30th of a second. Okay, so what camera will do is like, okay, I'm gonna take 1/30th of slice of time, slices in 4 times. One would be my long exposure, another time would be 1/200th of a second, another one will be 1/20th of a second, and another will be like 4 equal slices. And each of the slice will be even smaller. So long exposure will give you basically your low light performance, mid length will give you mid ranges, short exposure will give you highlights, ultra short exposure will make sure there is no clipping. Now here's the problem with this. It does work. From your point of view, it's like it's done in a single shot, but realistically it was done in, like, slices. Now problem is that at low light this breaks down. It's amazing at daylight. So if you have a Google Pixel phone, you shoot in daylight, it's like, damn son, this is good. That's why. The moment you pull it out in low light, it's like, okay, not bad, but like, it's generally very good for in those sort of scenarios where you have like Christmas lights, things of that, artificial light, a lot of artificial light, a lot of contrast. It still does work, but again, fundamentally limited by the fact that long exposure cannot utilize 1/30th of a second, because it has to basically complete the exposure inside 1/4 of a slice. Or sometimes again, camera algorithm can be smart enough where it's like, hey, I think it's a low light scene, we can only do 3 slices without compromising too much. Or maybe it was like, dude, it's ultra light, like super bright outside, or of course you cannot control aperture without interesting cost, so they may be like, hey, we're gonna increase these slices, so your video that you're getting out of mobile phone will look sharp. Why? The actual data, the actual frame is like, even though you may have 1/30th of a second, it would be like 1/4 of 1/30th of a second. So fundamentally very fast. Now problem, you can say this really does not save you. It's just like doing multiple exposure bracketing without you knowing. So what Canon is doing is like, hey, what if we do not have to worry about that? What if we can utilize 1/30th of a second full, which we'll call long exposure, and then in the select part of the sensor itself, we can control ultra short, mid length, short exposure, meaning you're taking this puppy and you're like, hey, I need this part to be long exposure, meaning 1/30th of a second. Awesome. But here's the deal. If I do 1/30th of a second whole sensor, this part gets blown out. Now, if I had dual gain, again, it does save it, but again, you do not get fine control there. It's good, but not great. But what if you have fine control? What if you like select this area, mask it, and be like, hey, sensor, please reduce the gain, this puppy to ultra short exposure. You like headlights and knobs, please put it to mid length. This area is like outside concrete, put it in short exposure. Now, you get a complete data in one shot, and there is no longer like, tricking you. It's not a trick, it's a raw. Now you were like, why the heck the output looks garbage? Again, it's breaking the law of nature. Like nature has infinite contrast. Our eyes adjust to infinite contrast. What we are doing here is like forcing all that contrast to go into a 8-bit video. You're like, what the hell? It looks odd again. So it does look ugly. And it does have complexity fabrication, because be mindful, all of those clusters have to have their own analog to digital converter, control wiring for it, and algorithms. And be mindful, because of the algorithm requirement, the fact that you need to control, it's not just like, oh, I have one long exposure, one short exposure. Like I have gradients in all of them, and just be mindful, this 4 does not mean it only has 4. It could be like very smooth gradient here. So they do need what we call algorithm data. That data will be coming from video frames. This is a video sensor. It can only work as video. It will not work in stills, because it will not have any idea like, oh, this area is getting overexposed or this is getting underexposed. It needs to know. How the heck it knows? It takes studies past 2 video frames to calculate a motion data, so it knows which direction, and then it extracts the basically brightness value and then projects that data physical, like the data mask. Basically it's a matrix controller data. That matrix controller data goes to the sensor gives the good data. That data becomes again T1 T2, brick by brick, you get amazing footage. Now, is it useful for mobile phone? Absolutely. Now, here's the deal. The output is garbage in terms of artistic quality, but in terms of scientific mathematical data, it's perfect. It has everything. Now, imagine this data going into your mobile phone, and then your AI algorithm that is on top of it, that Apple magic and that Google Pixel magic and that Samsung touch, all of that happens on this image. Now your mobile phone can be like, hey, I get it. This is the raw data, but I think we need to tone it down a bit. So at that point in time, it's like, hey, this area, let's show it down. Basically, add contrast to it. This puppy removes contrast. Now you have raw data. There is no place that is exposing. Now you decide to it. It's like, massage it. That's the only way you're gonna get amazing mobile phone video that has true HDR in one shot, and it's mind-bogglingly awesome. And if that ever comes to pass, be mindful at that point in time, mirrorless, DSLRs, all that jazz, bye-bye. Like flat out, this will bitch slap all of them. Even the big ass lens benefit will be gone away. So, and most likely it will be there, because be mindful, the sensor technology I'm talking, it's already there in high-end system. Regional exposure is not, because be mindful, even though Nikon built it and Canon built it, it's idiotically expensive. So it's only used for very high-end security camera applications, meaning like Pentagon security kind of thing. Normal people can't afford this sort of security camera. But from a security camera point of view, voila, I can see inside the car, I can see the number plate, I can see the make and model of this, I can see the tire pressure, I can see tire treads, everything, one go, take it and go. So they're like, shut up and take my money. And again, they do not even need to stretch the video to 10-bit, so it can store all that. They can compress it to 8-bit, so storage server will be filled up less. Again, if somebody made a movie camera out of this technology, I'm pretty sure they will try to store 12-bit of data. And then the projecting of that video will be another hassle. Be mindful, even this TV claims to be 10-bit. Many people say it's 8-bit, and there are only few panel manufacturers that gives you 12-bit panel. If you do not have that sort of panel, you cannot show it without it looking like, dude, it looks creepy, like no contrast. That's why, like, display certification is so complex. It's like, it needs brightness, it needs to be absolutely black, and luminance needs to be as high as like 4,000 for home use. For industrial use, it could be as high as 10,000 luminance. And again, if you are capturing that raw data, nature's data, it needs to be so bright that in nature, if you're looking on a, let's say, big projector screen, your eyes, the moment it goes to there, your eyes needs to adjust your aperture to capture it. So it's very difficult to make it look good. But again, AIs are like, give me this data, I'm going to polish it on the fly, and voila. And AI will love that, because again, it can see everything. Oh, this is a car. And again, I'm reasonably sure if this actually becomes a common thing, even the edge detection will become even more better. It's like, oh, that's a hair. Hairs will get like, short exposure, ultra short exposure. Or maybe even for hair, because again, hairs have motion. So they're like ultra short for one scene, one frame, short exposure for another. So it can isolate it properly while capturing the texture. So this is the most advanced technology of getting single shot HDR. Amazingly good for scientific, military applications and all that jazz. Really useless for us unless it's go through an AI layer, which makes it more presentable. Otherwise, like if somebody gave you this, you're like, ooh, looks bad. So this is the most amazing technology in terms of single shot HDR. Let's hope we can get this puppy in our mobile phones 5 to 10 years from now. So this was my presentation on single shot HDR technology. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me your disappointment. If would you leave a comment, I would try to read it and reply to all of them. And please subscribe, press the bell icon if you're free. And as always, thanks for watching.